Cubic functions which consist of a standard form of y is equals to ax cubed plus bx squared plus cx plus d, which your a is your slope, your d is your y-intercept, and then your b and your c, they're just values, right? Which you'll find out more about them later on. So now your cubic function, if you were to draw it, it looks more like this. You can simply say maybe it's two parabolas. If you were to draw a parabola like this and like this, you'll simply think that it's just a combination of the two, right? Okay, fine. So now the important thing about the cubic function is that we need to be able to identify its shape, right? So if, let's say for example, we have y is equals to ax cubed plus bx squared plus cx plus d, right? Which a is the gradient or slope. So to determine the shape of a cubic function, we use the slope. For example, if the slope of a cubic function is greater than 0, then the shape of our cubic function will be like this, which means this side of a cubic function is increasing, this side is decreasing, and this side here is increasing. So what I use is, for a is greater than 0, I can simply say I d I, which this means increase and this means decrease and this means increase, right? So now you know, if your a value is greater than 0, you have a cubic function with the shape of an IDI. So it's increase, decrease, increase. And then now if your value of a is less than 0, then this means that you have a cubic function like this, which here you can see that your cubic function is decreasing, and then here it's increasing, and then here is decreasing, right? So I can simply say it's d I d, right? Which d means decrease and the I means increase and the d means decrease. So for a cubic function with a less than 0, we can simply say it's did, which means decrease, increase, decrease. It's very important. Knowing the formula of a cubic function being y is equals to ax cubed plus bx squared plus cx plus d, if you find the derivative of this, we have y prime is equals to 3ax squared plus 2bx plus c. So what you need to notice here is that, okay, this is a cubic function. The derivative of a cubic function gives you a parabola. So now if you were to derive this further, you'll have 6ax plus 2b, which will give you a straight line, right? So now if you were to draw your cubic function, which is an increase, decrease, increase, remember an increase, decrease, increase, which is when your a is greater than 0, right? So if you were to just do this example, and you know that you have your turning points here and here, so since we have derived the cubic function, and I said to you we have a parabola which is established from a derivative of a cubic function, then what you need to know is that at the x values of the turning point, you will have the y-intercepts of your parabola, and since your a value is greater than 0, that means your parabola will be a smiley face. So you know a smiley face like this, right? So it means it's gonna look like this. It's gonna look more like this, passing through the intercepts. So the x values of the turning point of a cubic function are your x-intercepts of a parabola. And if you derive further, you will get a straight line. So if you derive the parabola, you will get a straight line, which is the second derivative of a cubic function. So the second derivative of a cubic function will give you a straight line, which is going to be vertical like this. So it's going to be vertical like this, giving you the x value of the turning point of a parabola. So the straight line that you derive from your second derivative of a cubic function will give you an x value of your turning point of the parabola. Sketch a cubic function, we'll need to follow the following steps. Step number 1 is to determine your stationary points of a cubic function, which is your turning points. Step number 2, you'll determine a shape. Step number 3, the x and y intercepts. So these are the steps that you will need to actually draw or sketch your cubic function. So let's say our example is y is equals to x cubed minus 4x squared plus 4x. So to derive this, which is our first step, you want to determine the stationary points. 3x squared minus 8x plus 4, and then you're gonna equate this derivative to 0. Why are you equating it? Because if you were to draw a function like this and you want these turning points here, at the turning point your gradient of the function is 0. So at the turning point your gradient is 0. That's why your derivative, when you derive, you're getting the gradient of the cubic function, so the gradient is 0. So now you're going to say 0 is equals to 3x squared minus 8x plus 4. Factorize these. We have 3x minus 2, x minus 2 equals to 0, x is equals to 2 over 3, or x is equals to 2. So the y values of your turning point, you're going to substitute in the original equation. Is 2 over 3 all cubed minus 4, 2 over 3 squared plus 4 into 2 over 3 will give you 32 over 27, and another y value equals to 2 into 3 minus 4 into 3, sorry this, and then plus 4 into 2 will give you 0, right? So now your turning point coordinates will be 2 over 3 and 32 over 27, and you also have your 2 and 0, right? So now the second step to find the shape, right? So if you were to draw the shape, you know that when a is greater than 0, it's what? It's an increase, decrease, increase. And when your a is less than 0, it's a decrease, increase, decrease. So in this case, if we check here, our a is 1. The a of a cubic function is 1. So our a is equals to 1. Therefore, our function is an increase, decrease, decrease. So we know that our function will look like this. So that's the second step. Then the third step is to find the x and the y intercept, which you know you have y is equals to x cubed minus 4x squared plus 4x. So you find the y-intercept and the x of this cubic function. So let's say x-intercept, y is equals to 0. You know y is 0 is equals to x cubed minus 4x squared plus 4x. Because x is common, you're gonna take it out and have x squared minus 4x plus 4. And then you factorize this here. So if you were to factorize x squared minus 4x plus 4, you will say it's x minus 2 and x minus 2, right? So you continue here, 0 is equals to x into x minus 2, x minus 2. So therefore, x is equals to 0, or x is equals to 2, or x is equals to 2, right? So these are your x-intercepts when y is 0. So you have 0 and 0, we have 2 and 0. And then your y-intercept when x is equals to 0, you have y is equals to x cubed minus 4x squared plus 4x, right? So if you substitute 0 here, 0 cubed minus 4 into 0 squared plus 4 into 0, you'll get a 0, right? So therefore, the coordinate is 0 and 0 for your y-intercept. So now you've done all your steps. You want to draw your function, right? So you go to your Cartesian plane, remember now your details of your cubic function. If you go back to the turning point of your cubic function, you'll realize that we have the turning point of 2 over 3 and 32 over 27, and then another one is 2 is to 0. So you're going to write them down here in your details. So your turning point is 2 over 3, 32 over 27, and another turning point is 2 and 0, right? So these are your findings, and your intercepts so if you go back and you check your intercepts here, you'll know that your x-intercepts, these ones, 0 and 0, 2 and 0, and your y-intercept is just 0 and 0. So you're going to write them down because it's very important. So you have 0 and 0, which is your x-intercept, and 2 and 0. Then your y-intercept, you have 0 and 0, right? So it's very important. And you know that, remember, looking at this, you know the shape of a cubic function. So now you know that it's an increase, decrease, and increase. So you know that it looks like this. So by drawing a cubic function now, we're going to plot our values. So if we plot 2 and 0, let's say 2 is here. So this will be the first point, the turning point, which is 2 and 0, right? And then if we plot 2 over 3 and 32 over 27, so we will have something like here, right? So let's say this will be 2 over 3 and 32 over 27. It's another turning point. And then our intercept passes through 0, and it also passes through at 2. Our intercept is also 0, and we know that it's an increase, decrease, increase. So it's an increase, decrease, increase. So we know that our graph is increasing from here, going up, and then it bends here because the turning point. Then it goes down like this, and because it's a turning point, it will bend again. So this will be your cubic function, which you labeled correctly. Thank you.